share screen. Oops. Oh. I think I just hit keynote. Okay. All right. My name is Brian Cardarella. I am the CEO of Dockyard. I hope some of you have heard of us. We're a software consultancy based in Boston, and we were very early investors in Ember. And we've been, for the past few years, building out full stack Ember solutions, staff augmentation for Ember application teams. So I also run Boston Elixir and the Boston Ember meetup. Phoenix, I'm here to talk about Phoenix today. Phoenix is a new player on the scene of MVC backend technologies. And I think it's one that most Ember application developers should be aware of and take into consideration for when they're talking about what type of technology should we have for the backend. Dockyard actually started as a Rails consultancy. I was doing Rails for over 10 years. We eventually migrated over to Ember being our primary technology that we were serving. And then we've completely stopped doing any Rails application development, any Rails staff augmentation. And we've adopted Elixir, which is the language Phoenix is built on top of, in Phoenix as our the backend for the stack offering that we have. Elixir, as I said, is the technology that it's the language that Phoenix is built on top of. But in order to talk about Elixir, we have to talk about Erlang. So this is taken from, I don't know, probably a Wikipedia page, but a general purpose concurrent garbage collector programming language in runtime system. That's how Erlang is described. And some people may look at that and go, huh, what? But I like to think of it as a highly scalable, all core consuming, CPU core consuming, fault tolerant, very fault tolerant system. Hot code swapping, functional programming language with terrible syntax. So Erlang was a project that started in the early 80s. It was a product of the Ericsson telephone network company. They had a need to replace a lot of hardware and probably some monkey patch software with a software system and language and ecosystem that would scale to global needs, have some very specific features of global telephony network, which is a highly distributed system. You have to have a system that is not going to go down often, if at all. And if you're making updates to the system, you don't want to take down the network in order to make an update. Erlang is still used a lot today in telephony networks. I think it's probably the most prevalent language used in cell technology. So you can think about the last time that that your telephone network messaged you to let you know that the network was going down for an update. It doesn't happen. The reason for that is because Erlang supports a feature called hot code swapping, where any patches to the system, you don't have to bring down the system in order to get those patches in. You can just load them right in. The software is immediately available, and everything runs smoothly. So highly fault tolerant. One of the sayings within the Erlang ecosystem is "let it fail." The reason for that is, and why that works with highly fault tolerant, is that there's a lot of work done on a lot of technologies in order to accommodate for failure state. And what Erlang came to the conclusion of decades ago, was that the best way to get back to a clean state was just to restart the system, right? It's that old thing where you're working on a Windows machine and someone says, oh, have you tried restarting it lately? Well, Erlang has adopted that philosophy. The difference here is that what they've built into the language is a process called the supervisor. And the supervisor are processes that watch other processes. And if there's a process that's misbehaving or has failed for any reason, that process is killed and automatically restarted. So you have this system of systems watching each other to make sure that everything's up. It was open sourced in 1998, along with OTP libraries. OTP is, you can think of that, it's more than just an std lib. It's more of like like common patterns and libraries for building out large distributed systems that aren't necessarily needed to be part of the language itself. It has the uninspired name of being the Open Telephony Platform or something like that. I forget. But OTP is really kind of the horsepower behind Erlang's application system. So well, I'm going to use the term application a few times during this talk. And in the Erlang world, application is what everyone else in every other language refers to as libraries. So a given library, like you can imagine, like Ember Islands, like was just spoken about, that would be considered an application within Erlang. The thing is about Erlang, as awesome as I'm making it to sound, it was ignored by nearly everybody for the next 17 years. The reason for this, I think, several, is first the syntax. It has, as much as people may dismiss syntax as being a reason to ignore a very powerful language, a lot of people that went into Erlang to check it out, I was turned off by it. Like I said, I did Ruby for many years. I think Ruby turned me into a bit of a syntax snob. And so just the prologue style syntax, which Erlang adopted, was very difficult for me to get into. The other side of it is that Erlang was very much an academic language. The community itself was very academically minded. It didn't have this same type of startup, like not open culture, because everyone in Erlang's mostly very nice too, but it didn't have the same type of feel that I got in the Ruby ecosystem and the Ember ecosystem. So there was a lot of, and it's been around for a very long period of time. I think as developers, we're just naturally sometimes, unfortunately, turned away from older technologies. We just dismiss it because of its shelf life rather than taking a look at it and deciding, okay, this actually is best for my use case. But some companies that are using Erlang in the wild today, Basho, they're responsible for the distributed database system called Riak. We have WhatsApp. They're not really big in the United States, I don't think, or maybe for younger generations, I'm not really into it. But the WhatsApp is kind of the poster child for the scalability of Erlang right now. I think they had less than 10 engineers working on the product. They got bought out for, was it like $1.5 billion? And with that small number of engineers, they were able to scale up a system that handled billions of messages per day. And a lot of that is due to not having to spend time scaling a system that's built under Erlang. They can focus on business value. And then Riot Games. Riot Games, of course, is responsible for League of Legends. They're using Erlang quite a bit for their communication system, I think live chat and such. So it never caught the attention of the masses until this guy came along, Jose Valim. So some people may be familiar with him. He was on the core team of Ruby on Rails. I think he just recently retired from that a few months ago. And what he realized was that he knew that people loved Ruby. The syntax, just the readability, how approachable the language was. But being on the Rails core team, he saw a lot of the issues that a lot of the challenges, I'll say rather. I think that's probably a more politically correct thing to say. A lot of the challenges that Ruby created for Rails, such as concurrency, scalability. And most of the time when you build out an application in Rails, a lot of the scalability strategies are known, but that's more time you have to sink into it. Even scaling up to what should be a nominal number of users is pretty difficult. But we're also heading into this world of real time. And Rails did just release Action Cable, but before that, Rails really didn't have any good real-time solution. And I actually do question if Action Cable is going to be a good real-time solution at scale. It's not proven yet, but we'll wait and see. Anyway, he knew that Erlang had a VM called Beam, and that he started wondering, can I create a syntax that just emits Beam AST and take advantage of everything that's great in Erlang? So here's my animations. He started experimenting this about 3 or 4 years ago. First pass on it was kind of an object-oriented version of Erlang that failed. and then he went full functional programming. So now he was able to marry what I think are the best of the two ideas between the Erlang ecosystem and Ruby syntax. In addition, he brought in a lot of other really nice things from other languages. Jose did have the benefit of being able to look at what has worked over the past decade or so for back-end web technology and what hasn't, and got to pick and choose what went into his language. The result of which is Elixir. So Elixir is a highly scalable, all CPU core consuming, fault tolerant, hot code swapping, functional programming language with awesome syntax and a powerful macro system. So a few other things on here I want to point out. All core consuming, why is this important? Languages that you're probably currently using on the back end, whether it be Ruby, Node, Python, these are languages that were written for and targeted a period of time in which the CPU companies were really trying to ramp up the amount of cycles each CPU spit out. And eventually they hit the limit, right? The limit is somewhere between 1.5 gigahertz to 2.5 gigahertz. Like Silicon is not going to go much faster. I know that there's some new material, graphene or something, is going to make, we're going to get 200 gigahertz any day now. But regardless, right now the CPU companies are competing on adding concurrency to their CPU, so they add more cores. The current, I'll refer to Ruby, Node, and Python as the current kind of generation of programming languages for the backend, or at least the most more popular ones among web tech. These don't take advantage of multi-core, whereas Elixir, because of Erlang, actually does by default. It gets a lot of its speed from its small processes. So the garbage collection strategy in Elixir is really not that different than Ruby's. The difference, however, is that it's doing significantly less work, because we have, rather than one giant world that the Ruby GC is collecting from, Elixir's is lots of tiny processes with very small memory footprints that can run concurrently. So while you may be done with a particular part of your application and that's getting removed from memory and memory is being cleaned up, that may only be a tenth of 1% of the entire memory footprint of your application, and it's happening completely outside of the runtime of the rest of your app. So this is where Elixir gets a lot of its speed from. In the macro system, you can think of the macro system as metaprogramming on steroids. It's actually really cool because whereas in other languages like Ruby and JavaScript, metaprogramming is essentially you're kind of writing the code that then gets evaled. What happens in macro system in Elixir is that you actually write code that emits AST. And so you are emitting kind of the base layer of Elixir and able to augment the language in any way that you want. In fact, if you were to go back and look at the Elixir source code, a lot of it is very readable because almost all of it's actually written in Elixir. Simple things that you wouldn't think would be, like if statements. If statement is actually just a function call. Well, it's technically a macro call, but that is written in Elixir, and it just delegates out to a conditional path. So all this stuff for me has been really fun to work with and get to know, but very mature tools. In addition, Elixir comes with a full document system. It comes with something called doc tests, which are really neat, where you can actually write in your docs. You can write example code, and these get executed and are a part of your test suite. It comes with XUnit, which is it's a very simple but very mature unit testing framework for Elixir. It comes with Mix, which is kind of like it's like npm and I'll say grunt to keep it in the JavaScript mind for a moment. Combined, it's a task runner. It's also going to go out and fetch and get all your dependencies and build tool and all that. It works really, really well. Hex is the repository where all the application packages are kept for Elixir, and Elixir does have a log file. I'll dig at npm for a minute, and they had that right from the beginning. So I want to show off some Elixir syntax. I will have to jump out of these slides. this one. Okay. So, oh, I'm sorry. Let me fix that. Is it better? Okay. So for those that may not be familiar with functional programming, the difference between functional programming and object-oriented programming is that in functional programming, you're never giving an instance of the object. The advantage there, in my mind at least, is that with instances, some people tend to think of it as saying, okay, a classic example, oh, I'm going to build this object, and each object's going to have some sort of behavior. I'm going to build a car, and this car is going to have an engine, and then I can inherit this car into a more specific manufacturer type car, and put in my own type of engine, and build out objects like that. Functional programming doesn't really concern itself with all that, because the trouble that functional programming says object-oriented programming has is maintaining the state of the application in your head. So when you have all these different instances that all have their own independent state, you can't look at any one point of the application and really grok, without having intimate knowledge of that system, what the state of the application is at any given time. Whereas in functional programming, it's just pretty bald-faced. So you can think of functional programming where we just are given kind of blobs of data, and we're just mutating that data through different functions that are passed to. In fact, in functional programming, we never call functions off of objects at all. So we have in, whoops, go back a slide. This could be, let's say this is Ruby for a minute. On top, we have a string, and we call downcase, and this is going to let us downcase. Whereas in functional programming, we actually have a string module. There are no classes in functional programming. And we call the downcase function. We pass in what we want to downcase. So for some people may look at it and go, oh, that's more verbose than what I'm used to. But over a period of time, we have found that it's actually allowed us to have more clear and concise code. And in fact, I'll show you some nice things that Jose brought into the language that will help kind of reduce some of the verbosity of the code. All right, so another example here would be if we're given an array and we want to add a new element to that array. In object-oriented programming, we have the object, which is the array here, and we're just calling a push function that's on that object because it's a type array, and we give it the object. Whereas in Elixir, we have this insert at function, and they're not called arrays in Elixir, they're called lists. And we have to, again, go through a little bit more hoop jumping, but we pass in the object, we pass in the position we want to insert it at, which is at the end of the list, -1, and we pass in the value. A Ruby example of iterator would be calling an anonymous function off of a map. So we're just mapping over this array, multiplying each element by 2. In Elixir, we have an enum enum module that is used for all enumerable types. So maps, lists, keyword lists, I think tuples too, I forget. But there's several different types within Elixir that are considered enumerable. And we pass in the object we want to, the value we want to enumerate over, and then we define this anonymous function, and it's basically doing the same thing. So there are 2 types of function definitions within Elixir. We have this kind of local or anonymous function equivalent. Here we assign it to a variable, and we use the fn. Oops. We use fn, and we just define it. We end it with end. And then in order to call it, we have to call the original variable we assigned it to and call dot, and then parentheses and the value that we want to pass to that. Whereas if we're doing module functions, we define them with def, and then we end them with end. And they should look pretty similar to what you're used to in other languages. Unlike Ruby, we're passing a do at the end of the function. On the first line of the function, rather, function definition. What's nice, though, is that you can define multiple versions of the same function name. So here we have 2 foo functions, and these can live side by side. In the first case, it will match against any calls I'm making to the foo function that I'm passing 2 variables to. In the second case is matching function calls I'm passing 3 variables to. In addition, we can actually put some guards on the function. So we can test what the state of certain values being passed in the function are in order to call a particular function. So here we have this when statement, and then there are a limited number of guards we can use. They're essentially just Boolean operations. It will result in a Boolean operation. So is odd, is even. And when I pass in foo1, it's going to call the first function. When I pass in foo2, it's going to call the second function. Now, this is an example of a kind of greedy matcher. Here I don't have any guards on the first line. And the second line, I would expect if I pass in 2 for it to match, but it won't because Elixir will just do the first matching function to win. Will win. So in this case, foo x with no guards on it is the winner, and it will happen both times. So even though we pass in 2, it will come back with odd. A module definition is defined with def module, and inside there we just define our functions. Now, one of the nice features in Elixir is the pipe operator. So some people may have heard about this. This allows you to really kind of clean up a lot of code that otherwise may feel hairy or is actually really difficult to refactor in certain cases. So this may look like code that everyone has written. I've definitely written code like this. If you were to think about it a little more kind of broken out, what's happening internally is that the baz function is being passed XYZ. The bar function is being passed the result of baz, and the foo function is being passed the result of bar. In Elixir with pipe operator, all it will do, it will take the original value and then pipe that in as the first argument of a function. So here we have XYZ, and then the pipe is this vertical line with the greater than symbol, and we just do baz and then bar and foo. And this really kind of, I think, is really nice for visualizing what I said earlier, where in Elixir, we're really just kind of passing data through different functions and mutating along the way. In fact, if you're passing other arguments to the function, everything kind of gets offset by 1. So in the case of bar function, and you're passing x as the first argument and 10 as the second argument, here we are piping in xyz as the first argument. Now 10, at least visually, looks like the first argument here, but it's really the second argument because xyz is still the first argument. The types that exist in Elixir, we have integers, floats, strings, char lists. So if you want to note the difference between strings and char lists, you'll see foo here with double quotes and then foo here with single quotes. There is, so if you're used to kind of going back and forth between double quotes and single quotes, or if you like using single quotes for strings, in Elixir you cannot. Char lists are a completely separate thing than strings. I'll demonstrate that real quick. So here we have, I'm in an IEX section, and if I have, let's say I do AB, let's do capital A, right? That comes back as capital A. But if I were to do 65 in a list, that also comes back as capital A. So that's what a char list is. So it's just really just a list of ASCII values, which a string also is, but this is how Elixir represents this internally. So if I do 90 here, we can build something out. But it's not the same as a string. You can convert between the two, but typically if you are working with strings, you got to make sure you're using double quotes. That can bite you. Lists are the equivalent of arrays. They can hold any number, any depth, and combination of types. Tuples have the syntax of what a JSON object would be, but they're not a JSON object. They're kind of a list, but they're not. They're really kind of used for return values within Elixir. If you want to return multiple values from a given function, you're typically using a tuple in Elixir. Maps are closer to what a JSON object would be, and Boolean is true, false. Then atoms would be like a keyword. Pattern matching. So whenever we're doing this statement in other languages, we're always doing assignment. However, in Elixir, we're not really doing assignment. We're actually doing equality. So here we can see that after I've said that x is equal to 1, I can then go and do 1 is equal to x. And Elixir will say, yes, this is fine because the two values are equal. But I can't do 2 is equal to x because that doesn't make any sense. You can reassign on the left-hand side. Internally, there is no, Erlang is an immutable language. And internally, Elixir will actually generate unique variable names. So while it looks like on the Elixir side you are reassigning to the original variable, technically under the hood you are not. We can take advantage of the pattern matching and the equality statements to a greater degree. So on the top here we have two lists, and I'm saying that x comma y is equal to 1 comma 2. What happens is that x is now assigned the value of 1 and y is assigned the value of 2. We can do it on either side of the equality operator. So we're using a tuple here with x comma 1 and 2 comma y. And again, x and y are assigned the equivalent value. As well within maps. What's really nice is that the pattern matching can be used with function definitions. So going back to this times 2 function, let's assume for a minute that x times 2 for whatever reason was a really, really expensive operation. We could actually speed up certain cases. And let's say 0 times 2 is an expensive operation, but we always knew the value was going to be 0. So we can define a new function definition of foo and say, okay, when it's past the value of 0, just return 0, because we always know that the result of this is going to be 0. Because it's going to, when you pass in foo, it's going to match that value. Now we can do the same thing when we're passing on lists, right? So we can say that for here, when we pass in the list of 2 and 3, the resulting value is going to be 6, because it's going to match the second function definition of x times y, 2 times 3, and that is 6. But for the bottom one, we're passing in 1 and 100. Now it matches the top function definition because the first element in that list matches. And now we just return y, which is 100. We can go to any depth. So if we have a more complex list, we can match against this properly. And we can even do recursive. Well, I mean, that's not anything special from language. Every language should be able to do recursion. But in order to do recursion properly within Elixir, we should be making it one of the last function calls. This is actually not a proper recursion call. It's just kind of demonstrating what may happen during recursion. To get the tail call optimization within Elixir, the last function call within a function has to be the recursive function call, if that makes sense. If it's not, then we'll hit a Stack Overflow bug eventually, if it's a very large recursion. This one is debatable right now. We keep batting it back and forth internally at Dockyard. Within the Pragmatic Programmer's Elixir book, Dave Thomas said that, hey, if you're doing private function calls, if you're defining private functions, which are defined with def p, you'll see down here, you should be defining it with underscore, or you should be naming your function underscore. We've actually shied away from this. And we'll call the function just something different. But some people are still doing it. Okay, so back to my other slides. Now this brings us to Chris McCord, who is the creator of the Phoenix framework. One of the really nice things about Phoenix is its speed. I think something that we see quite a lot for people that are just getting into Phoenix, they're blown away by the response times. Whereas in other languages and other frameworks, I'm used to seeing millisecond response times. In Phoenix, we're getting microsecond response times. Now, of course, if your server is in California and someone in Massachusetts is accessing the app, you're not going to get microseconds because you still have to deal with latent network latency. But at least the application is responding that fast. And then there are other things to consider as well. Is your database really going to respond that fast? But in most cases, like doing things like data serialization or just handling incoming and outgoing requests, it's incredibly fast. There was someone benchmarked Phoenix against other popular frameworks. And then other people took it and said, hey, you're doing this wrong, or like Go should be faster, or Node should be faster. And what eventually happened was that they got all of what were assumed to be some of the best, most optimized use cases for each of these different pieces of technology, and benchmarked it against Matthew Rothenberg's original Phoenix Showdown app. And Phoenix 0.13.1, which is actually much older than what's currently out. We're at 1.1 right now, 1.1.1, I think. And Phoenix and Plug, which is kind of the transport layer within, not a transport layer, it's like Rack or it's like Express for Phoenix. Well, for Elixir, and Phoenix is making use of it. Anyway, we're seeing some huge throughput numbers. Latency is incredibly low. These are order of magnitude kind of upgrades from what we were coming from at Dockyard at working with Rails, and this became a huge selling point for us. We had several companies where we would build Ember applications built upon a Rails app. They did not want to pay for, because they read the Lean Startup book or whatever they read. The word pre-optimization was kind of ingrained in their system about not doing. And then a month later, they would complain that their application was going slow, especially when you're dealing with a client-side application like Ember, that any latency of the app is really felt because we don't have that kind of visual cue of the page going blank for a second while it's loading from the server. So Phoenix kind of cleans a lot of this up for us. Chris actually did a benchmark. One of the compelling reasons to use Phoenix is its real-time features. In fact, Phoenix was built around this feature called channels, which allows you to use any transport layer, but primarily you probably interact it with WebSockets. So Chris was challenged to see how high he could scale up one Phoenix application server. And he was able to scale up one Phoenix application server to 2 million concurrent WebSocket connections. And these aren't just kind of lazy WebSocket connections just sitting there doing nothing. This was a system that was simulating a lot of heavy conversation amongst each other. Now, granted, he had a very beefy server that was handling it. I think Rackspace offered them. You can see right here, these are all the CPU cores on that system. And somewhere in there is going to be like the RAM. But regardless, doing this type of scalability with one application server in other languages and other frameworks is probably laughable. With the Phoenix, it's actually a reality. I don't know why I keep having the Phoenix pop up. So if you're interested in learning more about Phoenix and learning more about Elixir, I mentioned Programming Elixir by Dave Thomas. There's also the Programming Phoenix book by Chris McCord, Jose Valim. They are both available on PragProg. Programming Phoenix, I think, is pretty close to being released. It's still in beta. Programming Elixir, I think the current version of Elixir is 1.2, and I think a beta for the beta book for 1.2 just came out. I highly suggest reading them. In fact, Programming Elixir is probably one of the favorite programming books I've read in the past 10 years. It has some really interesting challenges. So if you're interested in using Elixir within your organization, because we were early adopters of the language and framework, we've run into several issues where companies are interested in the technology, interested in the potential, but have some issues about adopting it. So one of the first questions companies have is, how do I find engineers? Well, a story I'd like to tell you is that pretty much all of our engineers at Dockyard started as Rails engineers. And we took these Rails engineers, and there are 5 of them, 4 of which have previous Rails experience. We assigned all of them to read the first part of the PragProg Elixir book, which introduces the syntax, some of the concepts of functional programming. It's about 120 pages. I think 168 pages. They were contributing back to a production client Phoenix application after 1 week. Now, that's not to say that they were expert Elixir developers. That's not to say that what they were doing, I could go out and have them working on their own. It's to say that they took a lot of the concepts that existed in Rails, and these concepts are similar enough in Phoenix that all they needed to really understand was some of the functional programming ideas and syntax differences. So if you have engineers that are already familiar with other MVC frameworks, familiar with some object-oriented programming concepts, perhaps familiar with Python or Ruby, it's really not that much to transition them over to Elixir engineers. The other side of it too is why would I need to rewrite my application in Phoenix? Part of that would be maybe the company does not want to do the big rewrite. They're scared of that term. It's too costly. I agree with that. I don't think it's reasonable to just rewrite your app in a new technology just because it may be faster. However, there could be a convincing case for rewriting certain parts of your application in the new technology because it's going to allow you to do more with it. Now, let's say you have you've gone and you've gathered some information. You're using Skylight, for example, and you say, "Oh, these certain actions within my application are very, very slow." What you can do is that there's actually a library in Phoenix. I forget the exact name of it right now, but if you were to go on Hex and just search for Rails, it will actually allow you to share the cookie session between your Rails application and your Phoenix application. So now you can identify slow parts of your stack and slowly migrate them over to Phoenix. And you actually can have Phoenix handle the initial incoming requests and act as a proxy server over to Rails in instances in which it doesn't have an action to handle it. And then your data, you can connect any number of application servers to your database. We've done this with a client, and it's a slow way of migrating over. Maybe they don't need to migrate everything over, and maybe they just are happy with having those several different actions being handled by Phoenix. Whatever the strategy is, I do think that Phoenix can help. Oh, there's the result. Phoenix is in the middle. So that's a Phoenix. This part's more opinion. Taras, how am I doing on time? Hello? Oh, okay. 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 This shouldn't take too much longer. This is an opinion section here. It's about growing trees and kind of a philosophical reason why I think moving away from some of the more current technology over to something like Phoenix could be desirable. And it's taken from a book I read a few years ago called The Ecology of Commerce, at least some of the concepts. And bear with me, I'm kind of going off in a little bit direction here for a minute. Ecological systems, what can we learn from nature? How does this relate to business technology? So The Ecology of Commerce is a book about how we can affordably... Yep. Oh. Oh, okay. I don't know why it keeps turning me off. Probably 5 minutes. Okay, let me reshare this. Is it good? All right. Oh, what is going on? Okay. It's slow. Do you want me to give him a minute, or should I move ahead? All right, I will try again. I'll just try sharing Keynote directly. Yes, no? Okay, if it's a problem, I mean this part, I'll just keep it like this. If you guys can see this, I'll keep it like this and just step through the screens within here because it seems like whenever I go to full screen, it's blowing up. All right, let me step back here. All right, so Growing Trees, Ecology of Commerce is a book about how we can sustainably and economically kind of take in green technology. But there were some concepts in there that I found interesting that may equate to other types of technology and web technology and startups and so on. Primarily talked about ecological systems. What can we learn from nature? How does it relate to business technology? Two of the systems that defines within the book are immature systems. These are also known as pioneering systems. Examples of this would be weeds, grass, dandelions. And a quote from the book would be, whenever a disturbance violates an established ecosystem, aggressive and invasive weeds take over and spread quickly, establishing temporary primacy. These opportunistic species are suited to what are sometimes called immature systems. The plants compete for sunlight in order to capture the maximum available energy while trying to cover the raw earth as quickly as possible. In such a system, energy is wasted, diversity is minimal, and the plants are generally of lower quality and usefulness. Their life cycles are short, while their output is prodigious. Their use of resources is not very efficient. This is probably one of the best definitions I've ever seen, not intentionally, but for a startup. Startups are moving along very fast. When there is blood in the water, so to speak, for a particular type of business model, you see a whole bunch of startups spring up, and then eventually through regulation or market availability, there's going to be only a few winners. Mature system, a climax system. Examples of this would be trees or food. An ecosystem evolves from pioneering immature system states that emphasize growth until it evolves into mature systems that are highly efficient and resource conserving. Mature climax systems comprise an association of organisms that reach a state of equilibrium, which leaves the habitat largely unchanged from year to year. Because no environment remains unchanged, even the climax communities do not last forever, but they are more resilient to disturbances in greater environment. This would be a good, in my mind, definition of an enterprise company. A company that is very it's like a tree. It's got roots. It's stuck in the ground. It's not going anywhere anytime soon. It is susceptible to a change in the ecosystem. In fact, if there's some sort of change in the ecosystem in general, a lot of these mature systems are in jeopardy. But we can kind of loosely, just go with me for a minute, loosely say this would be a good idea between startups and enterprise. So to quickly summarize again, immature systems, quick growing, opportunistic, wasteful, at risk. Mature systems, slow growing, efficient. People disagree with me on this for enterprise, but I actually think enterprise companies are very efficient. Monopolistic and at risk. So something that we've seen as of lately, actually no, not of late, we've seen this for the past few years, or at least the press is always trying to gin up some sort of like, the sky is falling mentality. The bubble will burst. Snapchat valuation down, marked down 25%. This one. What's interesting, so David Osak's, what was the company? A few years ago, his company went public. And basically, he kind of gave everyone else, saying, hey, that's it. This is the last idea. My company has the last idea ever. And it was kind of this really, I thought, pretentious type of conversation. But what was interesting is at the end of his kind of rant, he goes, how many ideas like that are left? And if you notice at the bottom, if I can scroll down, Mark Andreessen came back and said an infinite number. Human creativity is limitless, which doesn't make it easy, but does mean the opportunity is unending. So we have to ask ourselves, what enables new ideas? I think that new technology enables new ideas. We see generally a cycle of technology, about a 10-year cycle between maturity, introduction, adoption, and maturity of technology. And I think for a lot of the traditional server-side technologies, we're pretty much a little bit beyond the maturation stage. They're well established, they're doing well what they can do, but now we need some new tech in order to really hit the next level of scalability, the next level of needs. If we just consider ourselves and say, okay, the SaaS product idea is played out, we can't think of anything new, then we're completely just selling ourselves off and saying, okay, we're not going to have any new companies, we're not going to have any new ideas. Everything else is just going to be derivative of what's already been delivered. But I think that Phoenix and Elixir are actually well poised to be one of the technologies to open up a lot of new ideas and new potential for companies. We're really excited about real-time at Dockyard, and I think that the marriage between Ember and a real-time backend as beefy as Phoenix presents a lot of opportunity for entrepreneurs to come up with brand new ideas, for new companies to be formed, for these startups to become their own mature systems and actually disrupt the ecosystem of the existing mature systems. All right, so finally, I'd like to end with some apps. And again, within Elixir, apps are libraries that we use at Dockyard. Libraries. Let's take a look at these real quick. So the first is JAWS Serializer. And this is a library that is going to allow you to emit JSON API very easily from Phoenix. It's written by friends of ours up in Vermont at another consultancy called Agilion. The creator, Alan Peabody. He wrote this library, and I think it was one of the first ones to do JSON API serialization and deserialization for Phoenix. And in my mind, it's probably one of the best ones. If you're interested in Phoenix and interested, hey, how do I get JSON API out of my Phoenix app? I would look into this. The rest of these are Dockyard libraries. So Voorhees, it will soon be renamed, but this is a library for allowing us to test and assert against JSON API payloads. It's very useful for because the JSON API schema is very verbose. This is useful for doing all those assertions very easily. Valid Field is another library that Dan wrote, and this is for doing validation testing within Ecto. Really, Ecto is the database library application for Elixir. Comes prepackaged in Phoenix. This allows us to do very easy validations. And finally is Ecto Fixtures. It's a library that I've been working on for building out test data very quickly. So that is it on Elixir and Phoenix. I hope that I at least interested some people on it. I will be at EmberConf, and if people are interested in Phoenix and Elixir, I'm happy to talk about it. We also have these Dockyard Elixir on the left and Phoenix styled stickers. So if you want some, come and grab me, and I'm happy to give them to you.